This video here covers how to solve a 3x3 system of equation. Notice there are three variables, and when you have three variables you need three equations to solve that. I'm going to do this by elimination, which means I'm going to get rid of x, y, or z. And you just kind of have to pick out which one is the best to get rid of. I'm attracted to getting rid of y because of the fact that we have plus y and minus y, and then here we have plus y and minus y. So it'd be easy to get rid of y. So here we go. I'm going to add together equation 1 plus equation 2. So I'm going to do E1 plus E2. So that's my notation so that I cannot mess this up too bad. So x minus y plus z is equal to negative 1. And then equation 2, is x plus y plus 3z is equal to negative 3. Then I'm going to add these together. Well, when you add these together, see what's going to happen is the y's are going to go away. X and x is 2x. 1z and 3z make 4z. And then this and this make negative 4. So that's the first equation that I need. So basically, I got to go from 3 equations and 3 unknowns to 2 equations and 2 unknowns. The strategy is to pick a variable and get rid of it twice. So that's our mantra for this. Pick a variable, get rid of it twice. So I picked y, and I'm going to get rid of it now a second time. So by adding equation 2 and 3 together, I'm going to get rid of it again. So I'm going to do equation 2 plus equation 3. So copy it down. Equation 2 is x plus y plus 3z is equal to negative 3. 2x minus y plus 2z is equal to 0. Now when I add these together, it's going to make the y go away again. So there's 1, that'd be 3x, cancels out, 5z equals negative 3 when you add those two together. So this is my second equation. Now I pretend like this doesn't exist because I have 2x plus 4z is equal to negative 4, and I have 3x plus 5z is equal to negative 3. So now I have 2 equations and 2 unknowns. So that's your goal, is to take this from 3 equations and 3 unknowns to 2 equations and 2 unknowns. And that's what I have right here, is 2 equations and 2 unknowns. So I pretend like this doesn't exist and I start over again. If I make this 6 and that negative 6, that would be good. So I'm going to multiply this equation here by 3. That makes that 6. I'm going to multiply this equation here by negative 2. That makes it negative 6. So I'm going to go over to the side here. 3 times 2 is 6x. 3 times the 4 is 12z. And the 3 times that would be negative 12. Negative 2 times this would be negative. This times this would be negative 10. And that times that is positive 6. So now I add these 2 equations together. So I picked a variable, y. I got rid of it twice, right? This then made a new system of equations here. So it made a new system of equations here. Then we put this and this together. We get 2z is equal to negative 6. Divide, z is equal to negative 3. So I have to back substitute my answer here. Then I take that answer and back substitute it up to here. So you got to do a double back substitute. So my first back substitute, my BS, is to put negative 3 in for z. So it's 2x plus 4z. I'm just using the first equation. It doesn't matter. First or second equation, but not the one that I've changed. Go back to the original one. So 2x, and then z was negative 3, and then there's that. So 2x minus 12 is equal to negative 4. Add the 12 over, 2x is equal to 8. Divide, x is equal to 4. Now we do the back substitute a second time. And I'm going to put that into either the first, second, or third equation. It doesn't matter which one I put it into. I like the fact that y is positive there. I think it'll make it easier instead of having the negative y. So I'm going to put it into the second equation. So it's x, which is 4, plus y plus 3z, which would be negative 3, is equal to negative 3. Now I just have to solve that for y. So let's see. So we get y, that's negative 9, and then 4. Negative 9 and 4 would be negative 5, wouldn't it? And then minus 3. Add the 5 over y is equal to 2. So x is 4. Y is equal to 2, and z is equal to 3. So I'm making a nice organized answer box here. In the world of 3 dimensions, this is an ordered triple. So you sometimes you'll see the solution 4, comma 2, comma negative 3. Instead of like an x and y dimension, there's a third dimension, z. So there's the answer right there. 4, 2, and negative 3, or 4, 2, negative 3 for x, y, and z. Okay, so pick a variable, get rid of it twice. And you can pick x, y, or z. In this one here, I'm going to get rid of x. Why do I want to get rid of x? Well, because you see, if I make that negative 2, then negative 2 plus 2 is 0. If I make it negative 2 again, negative 2 times, or plus the 2 here would be 0. So I'm going to choose to get rid of x twice. You could get rid of y twice like the last one. It doesn't matter, but you got to stick to your guns. Pick a variable, get rid of it twice. That's our mantra. And when you do that, when you pick the variable, get rid of it twice, it changes into a system of equations that we've solved in the past. So let's do that, and then you can try and finish this one out by yourself. So I'm going to multiply the first equation by negative 2, equation 1 by negative 2, plus equation number 2. All right, so I'm going to do negative 2 times the first equation. So E1 stands for the first equation. So negative 2 times x is negative 2x. Negative 2 times negative 2 would be plus 4y. Negative 2 times the 3 would be negative 6z. Negative 2 times the 12 would be negative 24. All right, now we're going to do the same. Oh, and then we're going to add the equation 2 to it. So it's 2x minus y minus 2z is equal to 5. So I just copy that one down. I'm only changing the first equation. So 3y minus 8z is equal to negative 19. All right, now I'm going to do the same thing again, except for I'm going to add it to the third equation. So it's negative 2 times the first equation plus the third equation. So I've already done negative 2 times the first equation, so I can just copy that down. So negative 2x plus 4y minus 2z is equal to negative 24. Then copy down the third equation, which is right there. 2x right here. 2x plus 2y minus z is equal to 4. All right, so I'm going to get rid of these. Gone. Minus 7z is equal to 20, negative 20. So I have this equation here, and I have this equation here. So my new system, I'm going to make a line across here. My new system is 3y minus 8z is equal to negative 19. 6y minus 7z is equal to negative 20. So what would you do now? So I'm like basically starting over again. But I'm forgetting that this exists, and I start over here and find out what y and z is. Once I get y and z, then I can put it back into one of those and get x. So I'd back substitute a second time. I'm thinking if this is 6, wouldn't it be awesome if that was negative 6? That's what I would do, multiply that by negative 2. All right, let's peruse through other parts of this worksheet here. This one here is actually easy, because pick a variable, get rid of it twice. Well, guess what? That's already been done. So the x plus 2z equals 5 is already done. I've already gotten rid of y somehow. So now I just get rid of y one more time. So what I would do is I would do the first equation and then plus negative the second equation. So I would do the first equation, 1, plus negative 1 times the second equation. And that will get rid of y for a second time. So for some reason, it's already been gotten rid of once. So you're going to do the first equation, and then negative 1 times the third equation, not the second equation, third equation. So that would make that negative y plus y, and then it's going to cancel out, and then you can go from there. This one here, I don't know. I'm thinking getting rid of x again, just because it's x and negative x. That would go away really quickly, and then you could make this 2, negative 2, and then positive 2, so you can get it to go away again. So pick a variable, get rid of it twice. That's what I would do. Here, and this is number 5. This can be done totally by substitution. So L is equal to 3w, so you can take the 3w, put it in for L. H is equal to 2w, so you can put 2w in for H. You can find w, then put it back in and get the other 2. This one here, one of the answers is a half, so don't freak out if one of the answers is a half. This one here, I mean, you got to just kind of figure out which one you want to get rid of. I would get rid of S first because of the fact that S is kind of yucky to work with. Those together by multiplying that by 2, so it'd be negative 2 and positive 2. And then you could do negative 5 and positive 5 to get rid of that. That's what I would do on that one. Here, more of the same, more of the same. Again, here one of the answers is a half. And this one here, we've already gotten rid of x once, so I get rid of x again. That one wouldn't be too bad. In fact, let's go ahead and do it. So I'm going to do equation. So this one's already good as gold. 2y plus 3z is equal to negative 5, right? And now we're going to get rid of x again. So I'm going to multiply this by 2. So it's equation 1 plus 2 times equation 2. Get it? So I'm going to copy down, copy, 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 and then I'm going to do 2 times this equation here, so 2 times all of it. So it's going to be negative 4x plus 6y plus minus 2z multiplying by 2 and then 16. Ooh, so this one's really easy because look what happens. That goes away, and I get 5y is equal to 10. So then, therefore, I know that y is equal to 2. If y is 2, look, I can put that right there. I can get z, and then I know y and z, and then I can put it back in there and get x. So try that one. All the answers are fractions. Woo-wee! All the answers are fractions on that one, so have fun with that one. And then there's some problems of story. So there's 4 story problems here. And they're basically just like the story problems that we did before, where you set it up and then you solve. Substitution, elimination, all that's kind of in place if you have 3 variables. This one here is from one of my 100-year-old math books. All right. Let's do this one here. A stadium has 49,000 seats. Seats in section A sell for $25, $20 in B. Section C is $15. The number of seats in section A equals the total number in B and C. Suppose that the stadium takes in $1,052,000 from a sold-out event. How many seats are in each section? So I'm not going to use X, Y, and Z for this one because it's A, B, and C. So I'm just going to use those. So A is the number of seats in section A, right? And then B would be the same thing, right? B is equal to the number of seats in section B. And then C, right? Oops. C would be the number of seats in section C. So I've defined my variables, right? So A is the number of seats in section A. B would be the number of seats in section C, or B, and then C, right? So the stadium total amount is 49,000 seats. So what would you write for that equation? 49,000 seats in all. Okay, well, all the seats together would be A plus B plus C. It would be 49,000. and then the money they take in. Well, how much is it for section A? $25 for each seed in section A, plus, and what would you write down? $20 for each C, or B, and then $15 for each C. And all of that should equal $1,052,000. All right. Now we need another equation. The other equation would be all the seats in section A are equal to all the seats in B and C together. So that's an easy equation. A equals B and C. So how do I say that? A equals B. That's not B. There's B. B and C. Just add it together. I would do substitution because look what you can do. You can take B plus C and put it into A, and you can take B plus C and put it into A again. So thus reducing it to two equations with just B and C. So if I put B and C in for A there, I get B plus C plus B plus C is equal to 49,000, right? And then if I take B plus C and put it into there, I get 25 times B plus C plus 20B plus 15C is equal to $1,052,000. So then, you can now simplifying, right? B plus B would be 2B, C plus C would be 2C, distribute, collect your like terms, and then you solve the system there. Okay? So that's kind of the deal with this. I've kind of given you a lot of hints and stuff like that. Go for it. See what you can do with it. All right.